Welcome everyone. It's 4:30 here in London, and we've got Kiran Bhagotra with us. She's the founder and CEO of ProtectBox, which is a cybersecurity company. And I know Kiran has an incredible story to tell you, but I asked Kiran to come and inspire you all and give you that boost. You're going to be on a very important journey from next week, next Monday. 9:45 a.m. is when I need you all to be tuned in. And I know the lockdown, relaxed us all, but it's going to be quite hard work over the next couple of weeks. And I want you to get the inspiration that you need to carry you over the next couple of weeks. And I thought, who could I have invited to do this very important job? And of course, it had to be Kiran. So Kiran, welcome. I'm so happy you are joining us today on a Saturday as well. So I'm very grateful. So it's over to you.
Thank you very much, Helena. I'm sorry it's such a rainy Saturday. I wish I'd got some sunshine behind me, but I'm so excited, so excited. I know everybody always says this, but I'm really excited to come and talk to you, not just because it's a Saturday or beforehand, but as some of you heard in the bit beforehand, if there's anybody that could have got things wrong in the way that they did things, it's probably me. I'm doing a video and I've got glare on my glasses and I shouldn't be wearing glasses. But I just wanted to give you a little bit of a taste of both my story, but also some of the areas that I'm really interested in. And I'm really interested to hear your views on some of those areas, because I've learnt from other people. So potted history of the story, so you know what the rambling Kiran character is like. I did very well at school. I was head girl at my school. I was quite smart, probably a geek at school, but I'm a bit embarrassed to say that. Did well. I went to medical school. Failed medical school, which I'm just about comfortable saying now, starting to tell everyone, writing articles about it as well. But while I was training as a doctor, I worked as a nurse. And that was, I was probably, 18, 19 then, and that was the very first failure in my life. And I'd had little experiences of failure, but I'd never really had a proper big experience of failure like that. And part of that was just, it wasn't necessarily the degree. Part of it was just the very sheltered life that I'd had, and just experiencing new things, and I wasn't ready, and also just part of being a grown up and learning that sometimes things are new and sometimes things are different, and sometimes they take a little bit of a while to just get used to. So failed medical school, and then was like, right, what am I going to do now? And I ended up going and doing a maths degree because I'd always really liked maths at school. And what I should probably go back and say is that when I was a young child, my father was quite ill. And that was part of the reason why I had gone into trying to train as a doctor, because I'd seen so many doctors, and I'm not just saying this for effect because of what's happening with COVID or whatever, but I'd generally grown up seeing my father looked after by so many doctors, and I wanted to do that job because they'd helped my father, and I wanted to do the same thing. But I hadn't actually thought about what I was actually good at and what I liked and what would fit me. So I went into medicine, did the nursing, saw this is really not what I want to be doing. And I'd loved maths at school, but maths was never very cool. It was never very trendy. It was never really the thing that you talked about. So when I left medicine, I went and did a maths degree, and I combined it with management. And despite having failed medicine, I got a first in my maths degree because I loved it so much. And I was very good at it because my mind is very logical, very rational, and it fitted it very well. I'm very good at problem solving, all those sort of things. And I just enjoyed it. And I had a part-time job. I did all the things that students did, and I did really well, and I got a medal and whatever, and I'm very embarrassed about all those things. But that was one of the things about stuff like resilience. Sometimes you have to, nobody ever tells you to think about what it is that you want to do, or what it is that you like to do, or think about some of the things that other people have views on what you should be doing, but there should be, it takes some time to actually understand what it is that you would like to do. And now, 20, 30 years old, I'm not going to go through all of the 20 and 30 years because they're very boring. Various careers in amongst all of that. I did a maths degree, I was an investment banker, I was a PR, I traveled around the world for a year and a half, almost became a scuba diving instructor, then went and worked for mining firms, worked as an investor, I've worked in government, I've worked in marketing, I've worked with lots of small companies, and now I run my own cybersecurity company. But out of all of those things, everything that I did has taken me to the job that I'm doing now, which is the job that encompasses all of those. But it's taken me about 20 years to work out that actually this is the thing that I wanted to be doing. So that's the thing about something like resilience, and I feel comfortable now with who I am versus what I was 20 years ago. But I'm still doing the same things, and I'm enjoying doing the same things that I did 20 years ago that I'm doing now. So potted history on my life. In terms of cybersecurity, AI, and blockchain, I'm going to try and share my video if I can. Share my screen. Am I allowed to do that, Elena? Share my presentation. It's not allowing me to do that.
Hold on, let me give
Sorry.
It's okay, don't worry. I will give you your permission to share.
Thank you.
Hold on. Can you check again whether you're allowed to share now?
Let me try now. Yes, I can now. Here we go.
Perfect.
So let me just... It's the joys of technology. You never quite get it all quite right. So everybody always asks me, so I run a cybersecurity company. I fell into cybersecurity, and I don't just say that for effect. I actually fell into cybersecurity probably about 7 or 8 years ago. I was working for a consultancy that was working in digital and was working with the Foreign and Commonwealth Office on cybersecurity. And one of the very first conferences that all governments around the world did on cybersecurity, I attended as somebody from industry. And I was very lucky and very fortunate to do that. And I don't just, I was just amazed that there was this whole world that was talking about things, about all the interconnectivity and all of those things. And then I ended up in a job completely inadvertently, again, falling into things always in cybersecurity. And when I was in that, because I have a mathematical mind, or a scientific, it's a combination of a mathematical and scientific mind, I always look into things and think about things. And this is I wanted to show you some slides. I didn't want to particularly put loads of slides together because I thought you might have had lots of lessons on AI and things like that. This is an article that I wrote, 2 articles that I wrote on blockchain in Wired and in City AM, where these were just things. So blockchain and quantum computing are, so I see quantum computing as the future of cybersecurity. Blockchain is very much now, it exists now. I think there are flaws in blockchain. There are issues around security, around protection from quantum. that I've written about, and I've put these articles here, but these were some of the slides that I put together on problems and solutions. And I thought about talking about each of the sections, because I was thinking, how would some of you will know about things like cybersecurity, and some of you will know about artificial intelligence, some of you will know about blockchain. And partly I said to you, write in the chat, tell me what you know about each of these things. But some of you might not know anything about them at all. And some of this is very, very complicated. Some of the problems at the top are very, very complicated. But some of the things at the bottom, in terms of the solutions, which are the things that you all will be involved in the future, will probably know an awful lot about. And I wanted to put these things up just to show you that this is one of the things that I learned through doing a maths degree and having a scientific background. This is how you look at the world, right? You look at problems, you look at solutions, and even some of the most complicated things like artificial intelligence, blockchain can be broken down into these things. And things like cryptographic hashes, key pairs, all of this stuff sounds very, very complicated, but it's actually really, it's just a way of defining what you're saying. So I wanted to put this, so in terms of whether you look at cybersecurity or whether you look at, so this is blockchain. This is what I see as the problems and the solutions for blockchain. And I wanted to, at this point, kind of throw it out to everybody. Has anybody heard of any of these things? Is there anything? Let me go back. Sorry, I pushed forward. I'm trying to find the chat now. Has anybody heard of these things? What would people like me to talk about in some of these problems and solutions? Or do people have opinions on these? Sorry, I keep clicking the slide.
So feel free to unmute yourself and say, express your opinion, unless you would like to message, and then I can read it out. So Kritik from Team 6 is asking, how are the new hashes made? Like, how was what? Kritik, why don't you just unmute yourself and talk to us?
Sorry, I'm trying to, I'm not doing a very good job on getting the questions on here.
Well, I know a bit about hashes, not too much, but I would like to know how they're actually made first. So I know there's SHA and AES and stuff, but how did they come about in the first place?
And then Sarah is asking you also, Kiran, what is blockchain?
So let me just click back on here. Oh, sorry. So the hashes, so the cryptographic hashes are all protocols that have been set by mathematicians or scientists. People will find, so when you get given an equation or a problem to solve, and you'll solve the problem through various versions of an equation, the hashes are based off of those equations. And equations are the very basis of algorithms. And what you will end up doing is you'll put together various equations, and you'll have multiple layers of equations and interactions between those equations that then become the hashes and the algorithms. So hopefully that critique answers your question.
So Jam is asking, why don't you unmute yourself, Jam, and ask your question?
Hi, Kiran. So normally in programming, we kind of come across, like time complexities and space complexities like ON, log n, whatever. So does this still stand for quantum computing in some respects, or is it totally blown out of the water?
So the N and the ON and the N, so it's still there. So one of the, so Schrodinger's, I don't know how many of the group have heard about Schrodinger's cat, where the cat can be alive or it can be dead. So what you've just said about the ON and the ON2, that is, it can flip between being, so with most computers, you have a 1 and a 0. So a 1 is a yes and a 0 is a no. What quantum computing does is it flips between the yes and the no. And it can be both at certain points in time. So with the ON and the ON2, it can also mimic both of those at the same time. Sorry, go on, you were going to ask me.
Sorry, yeah, that's a good point. So I was just really wondering, is as you kind of increase the qubits when you're like processing, is presumably the time it takes goes down, but does it go down at an exponential rate, or is that rate fixed or capped at some point? Like, kind of.
So it varies in the way that you do it. It varies in the way that you. So different quantum computers, depending upon the way that they are calculating that physicality of space. So some do it in vacuums, some do it in a combination of vacuums and encryption keys and space. Depending upon that, the time and the distance can vary in how you do that. So so I'm worried about the rest of the group in case they're thinking, what on earth is she talking about? Well, obviously, Jasper, he understands what I'm talking about. So if you're doing it in a purely like science where it's the atoms combining or the atoms exchanging, then that distance can be very, very small, and it can be microseconds. You know, even microseconds is a very, very long time when it's in the physical space or the physical scientific space. But if you're then exchanging those key pairs that are done as quantum key pairs over a network that could be the equivalent of a 5G network or could be a land to satellite network, then that time and distance will be amplified, or it'll be bigger, it'll be longer because of the network that you're passing it through.
Okay.
Does that make sense?
Yeah.
If you're doing it in the atom sense, in the scientific sense, where it's energies, transmitting energies, then it's very, very quick. It's astronomically quick. But if you're then having to process some of that, and I'm trying to say this in a way that everybody can understand, because it is really hard to say this in a way that everybody can understand. If you're doing it, so you think of like, you know, when at school when you learn about a cell breaks up and it reproduces, and one cell becomes 2 cells and things like that. When you're doing it like that, in that space that is within within our bodies or within a scientific space, then it can do it in nanoseconds. So, you know, less than the blink of an eye, even a fraction of the blink of an eye. And we can harness that, and you can harness that, and then you have to transmit it over existing systems, right? So you're taking something that is in a non-physical space, you're making it work at extra speed, and then you're having to push it through a very physical space. The physical space will slow it down, even though the non-physical process is very, very fast, because you're having to push it through the physical space. It's a hybrid, right? You're combining 2 things, so you've got to make them work together. And that's where things are slowing down. So that's where quantum computing exists, but it doesn't exist because it exists in the non-physical space. But when you have to push it through systems, it is slow. God, I've listened.
We will have a quantum computing workshop actually run on the Sundays. So this is probably would be a really good time to also ask about quantum computing. But as a moderator, I just wanted to remind everyone So Kiran's session is going to be lasting for another 10 minutes. So Kiran, you have limited time. Kiran will be in Discord. So if you would like to ask her some other questions, ideally in the public forum for safety of everyone's, so please do ask the questions in Discord. Okay, so Kiran, another 10 minutes, and we have another speaker who is joining us now.
Sure, sorry. So Sarah asked the question, what are blockchains? So blockchains are, they call it distributed ledger technology. So one of the easiest ways of describing it, so distributed means that it's spread around. Ledger is an old-fashioned word for splitting something up. And then technology is that it's just software or online based. So if you take a whole string of, you have a lot of information about customers or about a process, you break that process up and then you put it in lots of different places. So one of the things I said in my article is that if you, something that's very important to you, so like if you own a house and your jewelry is very important, not to maybe to everyone, but I'm a girl, so my jewelry is very important. I would possibly put it in a safe, but if I were going to put it on the blockchain to keep it safe, I would take all of my rings and necklaces and earrings and everything like that, and I'd put them all in separate jewelry boxes, and then I would put all those jewelry boxes all around the world. That's essentially what blockchain does, but it does it online on the internet. Hopefully that answers that question. I think it did, because Sarah said yes, and I think Jasmine Root said yes, that was very clear as well, even though I didn't think it was very clear. That's actually not one of my simplest answers. So on AI, does anybody have any questions on artificial intelligence? Oh, that's very interesting. So Charlize has asked, this might sound silly, but do you reckon that med school helped in any way when you got into cybersecurity? So yes, it probably did help in that it helped me understand that my mind was more of a mathematical mind than an empathetic mind, which is possibly, I'm not saying that people in cybersecurity are not empathetic and are not caring or kind, but anybody who works more in health and as a doctor or a nurse cares is more about caring about people as about non-people and technology. But interestingly, one of the things that I always say about cybersecurity and about AI, one of the things that I'm trying to do is actually, so a lot of people talk about the ethics of AI. I wanted to cover some of that, some of the bias and some of the ethics, but I could talk on forever about that. And I wanted to let you guys talk as well. The way that you build ethics and lack of bias into AI is by having done things like medical jobs, because you think about people, you talk about people. And I often talk about the fact that with cybersecurity, one of the things that we're trying to do is actually make it the way that people want to use it, as opposed to just very technical. Just bringing some of the technical stuff together with some of the people stuff. So yes, that's the very convoluted answer to the question, that actually medical school helped in that way, because actually my foundations come from a very people-based background as opposed to a very technical-based background. I can code, I understand code, I'm very mathematical in my thinking, but actually one of the very first things that I did in my life was not technical and was more people-based. It also adds the fact that anyone in the world can verify that the diamonds stored are still there and not tampered with. This is from Marcus Norton, inside of a vault somewhere where only one person can. So yes, absolutely right. So that is the how Marcus has described that is exactly how blockchain describe it as being tamper-proof. The thing that quantum computing can do is that there is, so the analogy that I use is that that lockbox that you've got your diamonds in that you've put around the world doesn't actually have a physical lock on it. And what quantum computing is the thing that, you know how when you see on like CSI and things like that, where they go up to the lock and they break the lock with one of those great big like crankshaw things, that's quantum computing. That's the equivalent of quantum computing for one of those things. What blockchain is doing is putting all of these boxes, you know, these jewelry boxes with your very special jewelry in it with no lock on it. So quantum computing doesn't even have to break the lock, but if you put a lock on it, quantum computing could still break that lock, no matter what that lock was. So that's the thing about it. And then Rachel has asked, is quantum computing the best way to solve computing problems, as most of the solutions consist of this? So I am a little bit biased on this. I'm a quantum computing advocate. So I really believe in it, and I do think it is the way. So I don't think it's going to solve most of the computing problems. What it's going to do is speed up a lot of computation. So the way computers work at the moment is because of, like I said, that 1 and 0. That 1 and 0 doesn't exist anymore in quantum computing. You know, 1 can become 0, 0 can become 1, the 2 can become, you know, both of them can be the same thing at the same time. So it's almost like you can do things so much, when you could only do things in 2 dimensions, when you can suddenly do things in 3 or 4 dimensions, it opens up a whole load of possibilities. So some of the things like renewable energies, they're talking about batteries that are powered off quantum batteries. So some of the stuff, and I'm going to sound very sensationalistic here, but some of the Neuralinks that the likes of Elon Musk are building, those, because of the way our brains work, you know, if you put a chip onto our brain, you need super computing power. So what quantum does is it just computes at an exponentially faster rate, right? So 1 and 0 can do 10 times. Quantum can do 100 million times compared to 10 times. So that's the difference. So that's what quantum does. It just makes everything 10 times faster. So if you build that into things like batteries, like, you know, a chip in your head, so our brains work super fast. So if you get a chip that is a lot slower version of our brains and you connect it to our brains, and all of a sudden it works really fast. Sorry, Elena, 3 minutes. 3 minutes. I'm on 3 minutes. So what would anybody else like me to talk about? Thank you, Rachel. Wow, that is very interesting. I hope so. I genuinely hope so. So what are your views? What is everybody else's views on? So what is the best route? Sarah's asked, what is the best route to get into cybersecurity? So there are an awful lot of programs. Cyber for Girls that the National Cybersecurity Centre does. I don't know what, sorry, I don't know the exact age range for this group, but Cyber First, and there are various programs for girls, and it's not just for girls. There are CyberStart. There we go. Thank you, critic. CyberStart, Cyber for Summer. Cyber First is the other one as well. Thank you, Elena. So Elena's put out the Cyber First one. But there's also Cybersecurity Challenge as well that I've judged before. So that's one of the ways to get in. But there are they call them MOOCs, mass open online courses. So they're kind of the equivalent of a university degree. So you guys could go off and do another degree, but you could do a MOOC alongside it, or you could do one or the other. There are also apprenticeships as well. The National Cybersecurity Centre runs those. The Cabinet Office run those as well. I can find you those links, and I can send you all of those links afterwards as well. Future Learn as well is what Elena is putting up there. But there's an awful lot of there is just a general amount of content around cybersecurity. So we've looked at internships here at ProtectBox. A lot of cybersecurity companies also look at internships as well. A lot of universities have designated programs that work with companies like ours, like ProtectBox and other companies. So most of it tends to be at degree level. The courses that I've mentioned to you tend to be more at school level, but there are masters now. There are designated degree programs as well, that if you really wanted to just focus on cybersecurity, but I've always been a big advocate that you can do another degree and you can do cybersecurity on the side. And one of the things that we've always been trying to do at ProtectBox is almost, and I don't really want to describe it exactly the same as Uber, but you could almost do cybersecurity as a kind of Uber job alongside another career, and and it could become a proper job as well. But there are different ways of getting in. Oh, Elena sent an excellent one, the apprenticeships. Perfect. Sorry, I should have got all of these ready as a reading list. So am I still within my time limit? Almost.
Well, you do need to wrap up because we have Conrad already on the call, and I know Conrad also has evening plans, and we were planning to have him at 5, but we could schedule another session with you, Kiran, because I can see there are a lot of questions and a lot of interest in blockchain, quantum computing. So we could have another session with you at some point, and we could angle it around, one of the technologies or whatnot, for sure. But I just found some really amazing links. Everything is obviously on Google. Some of the apprenticeships have expired because there is a time when hiring happens around apprenticeships. But there is lots and lots happening in the cybersecurity space, girls in particular, which is really obviously fantastic. So just Google basically, and you will find.
So the way that I would close off is there's an awful lot of stuff out there for girls, a lot more than there was when I was at the kind of stage of, like, when I was going through this, and I only ever saw maths or science. You have maths, science, and technology and cybersecurity now, all as choices. And what I would also say is, so some of the best advice that I have got as a girl going into cybersecurity, okay, I'm not a girl, I'm an old woman now going into cybersecurity, is the guys are a perfect way in, right? So the guys shouldn't be left out of all of this as well. And the girls do need more representation, but you need to work together. And it's the same way in an awful lot of industry. Most of the industries that I've worked in have been heavily male dominated, but I've got where I've got to because the guys have helped me to get to those places. So I just wanted to put that out there as well as the last piece. The balance is there, and the balance is growing, and the balance grows because of the guys. Anyway, so I don't want to take away from the next speaker. Sorry. I should. Hopefully the next one will be
brilliant. All right.
Will be a lot more organized and sensible than mine. But in the way that you can, I'm perfectly happy to come back on and do another talk if you've got defined questions about blockchain, or I'm fascinated about this stuff. And be intellectually curious, right? If you're curious about the stuff, don't let anybody put you down about it. Ask the questions, and it's amazing. Quantum was just something that I was absolutely fascinated about. It's not even something to do with my career particularly. I'm just super fascinated about it because that's where I see society going. So if you feel the same way about any of these things, ask those questions. look into that information. Anyway, I'm going to stop.
Kiran is on Discord as well, so you can always ask those questions, and Kiran will be happy to respond. Okay, so on this note, well, Kiran, thank you so much for your time. Thank you
Good
for
luck.
joining us today.
Good luck, folks. Enjoy.
If you could stop sharing the screen, then I can introduce
I will. Sorry.
Conrad as well. Amazing.
There we go.
Thank you, Kiran.
Thank you.
We're happy you're joining us. You are in Discord, and you will be joining as a mentor as well.